Hello everyone, Mr. Fawcett here, and we are back with another Algebra 1 video. We're going to continue our discussion on inequalities today, but we're going to start talking about some word problems. So just like we did word problems with equations, now we're going to do some word problems with inequalities. First thing you can do is solve and graph the compound inequality below. This is just a review from our last video where we were solving compound inequalities. Now remember, there's two types. There's and or. So based on which type it is, that's going to tell you what you need to do when you graph it. All right, so pause the video, maybe go back and look through your notes and attempt to solve this one. Okay, so because it's written together, this is going to be an and inequality. So we can start off knowing that. I need to break it up, so I'm going to write negative 19 is less than 3n minus 7. That's one piece. And my other piece is going to be 3n minus 7 is less than 5. And now we just have to solve both of these. So I'm going to add 7 to both sides. That's going to give me negative 12 is less than 3n. I'm going to divide both sides by 3. And I'm going to get, again, I always start reading with the variable because I think that makes the most sense. I get n is greater than negative 4. Again, you could say negative 4 is less than n. I just don't think it helps you understand how to graph it as well as saying n is greater than negative 4. Okay, let us move on to the green. So I'm going to add 7 to both sides here. That's going to give me 3n is less than 12. Divide by 3. And I get n is less than 4. So now I need to go ahead and graph both of these inequalities. Let's go ahead and graph the red one first. I have n is greater than negative 4. So I have an open point because it's just greater than. And I'm looking for numbers greater than negative 4. So I'm going to go this way to the right on my number line. If I graph my green, I have n is less than 4. So again, an open point. And I'm looking for numbers less than 4. So I'm going to the left. Now this is an and inequality, remember up here. We established that at the beginning. So I need to look for solutions that work for both the green and the red inequalities, right? So an easy way to do that, if you're color coordinated, you can look at where the overlap is. Where are points on this number line that have both a red and a green line above them? Because that means they're going to work for both. And our solution set for this compound inequality is from negative 4 open point to positive 4 open point. This black segment is our solution set. All right, so you need that black one. You could actually erase all the other ones if you wanted to afterwards to show clearly what your solution set is. Okay, let's move on, start doing some word problems. So number 1 says, write an equation to find x, the number of meters that Skylar would need to add to her personal best if she wants to tie the district record. So if we look at the picture, Skylar is a high jumper. Her personal best is 1.48 meters. All right, the district record is 1.57 meters and the state record is 1.75. So we need to write an equation. Again, we're starting off with an equation. We'll get to inequalities. That we need to write an equation that shows us how many meters Skylar would need to add. So there's a hint, add to her personal best. So 1.48 plus x, because x represents the number of meters she needs to add, to tie the district record. So she needs to tie or equal the district record, which is 1.57 meters. And then we could go ahead and solve it. It doesn't ask us to, but we could. We would just subtract 1.48 from both sides. And we would see that she needs to add 0.09 meters to her personal best. Okay, so again, this was just an equation. Let's take a look at number 2 and see what we need to do to come up with an inequality. So number 2 says, change your answer to number 1 to an inequality so that it represents the number of meters that Skylar could add to her personal best to break the district record. So remember that our equation was 1.48 plus x equals 1.57. That would be if she wants to tie the district record. But if she needs to break it, right, she needs to get more than 1.57 meters. So think about what sign that would be, right? What inequality sign. And if it needs to be more than, well, that's just greater than, right? So that would be our inequality if we're talking about how many meters she needs to add to actually break the district record and not just tie it. Pause the video, try to answer number 3 on your own. It's very similar. All right, so it just says write and solve, so we need to solve it this time. An inequality that represents the number of meters Skylar would need to add to her personal best if she wants to break the state record. So it's the same setup, 1.48 plus x. We need to break the state record, so it needs to be greater than 1.75. 1.75 is the state record. So if we subtracted 1.48 from both sides, that gives us x is greater than 0.27 meters. So she needs to improve her personal best by more than 0.27 meters to break the state record. Okay, so again, just a very basic setup here. The problems will get a little bit more complicated, but again, same idea as an equation. We try to come up with two things that are related to each other some way. It just so happens with inequalities, we have to pay attention to what sign we're using. So it may be greater than, it may be less than, it could be greater than or equal to, or less than or equal to. So the new thing we're doing today is understanding what sign to use. Before, we just always used an equal sign because we were doing equations. With inequalities, it becomes a little bit more challenging because we have 4 different signs to choose from. All right, let's move on to another example. All right, number 4. It says David has $500 in his bank account at the beginning of summer. He wants to end the summer with at least $150 in his account. And each week he withdraws $25 for gas and snacks. So part A says write an inequality to represent the number of weeks he can withdraw $25 without going below $150. Let W represent the number of weeks that he withdraws $25. So they're already telling us what our variable is going to be. It's going to be W. Now, he starts with 500. All right, so I'm going to put 500 here. Now, every week, he withdraws $25. So if it's 1 week, it's 25. If it's 2 weeks, it's 50. If it's 3 weeks, it's 75, etc. If we're withdrawing, we're subtracting. We're taking away from the 500. And it's going to be minus 25 times W. Right? Because we're going to multiply that $25 by the number of weeks that he withdraws. Now we know that this amount of money, right, he wants to have at least 150. So he wants to be at 150 or above. So this quantity right here is the amount of money that he's going to be left with in his account. He wants that to be greater than or equal to $150. Right? So that's why we're using greater than or equal to here. Now we just need to go ahead and solve. So we're trying to get W by itself. I'm going to subtract 500 from both sides. That's going to give me negative 25. W is greater than or equal to negative 350. Then I'm going to divide by negative 25. Remember that if you divide by a negative number, you must switch or flip the inequality sign. So it's going to be W is less than or equal to Negative 350 divided by negative 25 is positive 14. So he can withdraw $25 for up to 14 weeks, right? Any amount of weeks up to 14 is okay. But if he withdraws 15 weeks, right? If he withdraws $25 15 times, then he's going to have less than that $150 that he wants to keep in there. So we can write out a little sentence. We can say he can withdraw up to, actually, let's rephrase a little bit. He can withdraw $25 up to 14 times. Or you could say he could withdraw $25 no more than 14 times. Now you may be thinking about this and you may say, Mr. Fawcett, there are some numbers that are less than or equal to 14 that wouldn't make sense for this problem, right? Maybe you're thinking, what about negative 5? Negative 5 is less than or equal to 14, but can I have negative 5 weeks? That doesn't make sense, right, when I'm talking about time. So in this case, again, I would accept this answer because that's kind of at the level where we're at right now. This is the answer that makes sense for this problem. However, if we think about it on a slightly deeper level, if you want to take that further step, if you understand everything we've done up until this point in this problem, and you want to take it a step further, you could also think about it like this, right? W actually also has to be greater than or equal to 0 because we can't include those negative numbers. So a better answer here would be W is greater than or equal to 0 and less than or equal to 14. Right? And if we were graphing our solution here, we would certainly not look at any numbers that are greater than 0. So again, this is just thinking on a slightly different level here. Sometimes we have to think about, does our solution set make sense for this problem? So we set it up as a single inequality, but at the end we had to think, okay, are there any other constraints I need to put on W? Is it possible for W to be negative? If it's not, you may need to add on another inequality to show that W also has to be greater than or equal to 0. Again, so that's just kind of taking our thinking to another level when we're talking about real-world scenarios. Let's do one more. Well, I think we actually may do 2 or 3 more. We are going to do number 5. So it says Jennifer wants to order some roses for her mother on Mother's Day. She has 2 florists in her neighborhood. And the question is, for how many roses would florist B be less expensive? So we want florist B to be less expensive than florist A. So we're going to write out an inequality to represent the scenario where X represents the total number of roses Jennifer buys. So I'm going to start with this sentence right here. For how many roses would florist B be less expensive? So we have florist B and we have florist A. And if we want florist B to be less expensive, well, that means florist B's cost should be less than the cost of florist A. So now we need to just come up with some algebraic expressions for the costs of florist B and florist A so we can get rid of the word expressions that we currently have. All right, so florist A, $4.75 per rose plus $40 delivery. So if X represents the number of roses, well, we're going to do for florist, we'll do florist A first, I guess. Keep our inequality sign. So for florist A, we have 4.75 times X, because it's 4.75 per rose, plus the $40 delivery charge. That's just a single fee. It doesn't matter how many roses you're delivering. Florist B, we have $5.15 per rose. Let's make that a better 5. So times x plus only a 25 delivery charge. So that would be the inequality that would help us figure out how many roses we could order where florist B is less expensive than florist A. And now they're just asking us to solve our inequality. So I'm just going to start from where we're at. I'm actually going to get rid of this box and then go ahead and solve. I'm going to subtract 4.75 from both sides, 4.75x to be exact. That is going to give me 0.4x plus 25 is less than 40. Subtract 25 from both sides, and I get 0.4x is less than 15. I'm going to come up here. I've got one more step. Divide both sides by 0.4. And that is going to give me x is less than 37.5 roses. So again, as long as we order 37 roses, because we're assuming you can't order 37.4 roses. So if we order 37 roses or less, or we could say less than 37.5 roses, florist B would be the cheaper option. Now again, we could think about this on a deeper level. Do all of these numbers work? Does any number less than 37.5 work, right? Well, no, negative numbers aren't going to work here. Sometimes negative numbers work, right? There are some word problems where you can have negative numbers. But we're not going to get into them right now. We're just going to think about this problem, and you can't order negative roses. So you could say that x has to be greater than 0. Because if you order 0 roses, then both florists cost the same, right? You're going to pay $0 to both of them. So you don't want to say greater than or equal to, because you have to order at least one rose for florist B to be less expensive. So x is greater than 0, but it has to be less than 37.5. This is just again, a slightly better way of answering this problem, because it assures the reader that you cannot order negative roses. That may already be implied, and again, on a test that, a test that's written, this just may be one of the answer choices, right? I'm not going to have both of these answer choices on here because I'm not going to try to confuse you that way. But just know that, technically we could say that x needs to also be greater than 0, right? Because we can't include negative values of x. Alrighty, let's do one true compound inequality word problem. Up until now, we've just been doing single inequalities, except for that little discussion at the end. All right, so this question is going to take up the entire page. Maybe I can fit the whole thing. Nope. Oh, just barely. All right. So it says Jonathan wants to host an NFL party on Sunday. He knows he will need to spend at least $24 on food, but doesn't want to spend more than $54. And he's going to order pizza, which will cost him $6 per pizza. So he's ordering pizza. They cost $6 a piece. He wants to order at least $24 worth of food, but he doesn't want to spend more than $54. So think about this. Think about whether this is an and compound inequality or an or compound inequality, and then state your reasoning on the lines below. Pause the video here, and then we'll come back and discuss. All right, so I just typed it because it was quite a bit to type. But this is an and compound inequality because Jonathan has to come up with an amount of money that fits both constraints, right? It has to be at least $24, but it also can't be more than 54. So it has to fit both of the constraints, which means it's an and. So think about when we graph this, right, we're going to be looking for that overlap. So let's start to set up a compound inequality. You can write this two ways, right? You can write it together or you can write them separately and just put an and in between. I think that's the easiest way. It does say that we're going to use P for pizzas. Okay. So the first inequality is that the amount he spends must be greater than or equal to 24. So the money he spends on pizza, we can say that's poor. We can say cost of pizza must be greater than $24. But then we have another one, right, where it says cost of pizza is less than or equal to, we actually need to fix this other one, greater than or equal to $24. And the cost of pizza has to be less than or equal to $54. So what is the cost of the total pizza he buys? Well, there's $6 per pizza, right? So that's $6 times the amount of pizzas, which is going to be represented by P. So 6P is greater than or equal to 24. I solve by dividing both sides by 6, and I get P is greater than or equal to 4. So I solved my first one. I come over here. The cost of the pizza is the same, right? 6P is less than or equal to 54. Divide both sides by 6. And I get P is less than or equal to 9. And now we just need to graph, right? So if I graph my red one first, greater than or equal to 4, close point, and I'm going to the right because these are the numbers that are greater than or equal to 4. And then I graph my green, close dot at 9 because it's less than or equal to, and I'm going to the left because that's the numbers that are less than or equal to 9. This is an and inequality, right? Our solutions have to work for both the red and the green. So I have to just look at my overlap. So my overlap is from 4 to 9. Right? So that is really what my solution set should look like. And then you can erase your previous work and just leave your solutions on here. Now I think there's one more question. Let me quick see if it's at the bottom here. I hope I put it in your notes. Yes. So it says, should we use a solid line to connect the points on the ends of our solution set? Why or why not? Well, if I use a solid line here, right? Let me get my pen out again. If I use a solid line, that means I'm including all the numbers between 4 and 9. That's all the decimals and all the fractions. So like 4.1, 4.27798654289, etc. Right? Pick any decimal that you want. Does that make sense for this problem? Again, we're thinking on a little bit of a higher level than you've been asked to think before. Well, if we're talking about pizza, does it make sense that I include all of the decimals and the fractions? Can I buy a half of a pizza or 3/4 of a pizza or 0.17829 of a pizza? Well, most likely you can't, right? I've never heard of a pizza place that says, sure, pick any, percentage of the pizza and we'll sell it to you. It's usually you have to buy a whole pizza. Sometimes you can buy by the slice, right? But even then they have preset slices. Right? You can't say I want 1/4 of that slice, right? They're just going to say, no, you got to buy the whole slice. So a slightly better graph for us would just be to plot the whole number points. Right? Jonathan can buy 4 pizzas. He could buy 5, 6, 7, 8, or 9 pizzas. Those are his options. So there are multiple solutions here. But there's not an infinite amount of solutions like there are with other inequalities, right? When we're just solving a regular problem, we can include all the numbers between 2 points. Other times, though, right, we have to stick with our whole numbers. If we had been asked to graph some of the inequalities up above, where we were talking about weeks or roses, we would also want to employ this strategy, right? We would also only want to graph the whole numbers, because in these examples, we can't break down roses or pizzas into those decimals. So just another thing to think about when you're doing word problems, always think about, does my solution set make sense? Are there numbers that I shouldn't include based on the fact that this is a real world scenario? Okay, we're going to stop there for this video. We have gone long enough. You do have some ones you can work on, though, throughout the rest of this packet to get some more practice in. So enjoy the rest of your day, and I look forward to seeing you with our next video.